In this video, we're going to look at the vanadium ion question. So it says a chemical reaction is carried out in a sealed syringe. Vanadium-3 and waters and bromine react to make this vanadium oxide ion with hydrogen ions and 2 bromides. So this is an equilibrium system. You've got some colored species. The vanadium-3 ions are green, the bromine is red-brown. The vanadium oxide ion here is blue. If we had all of those colors mixed together, it's going to be a bit of a probably browny blue mess. But we're going to refer to the colors as how we're going to see a change. So it might actually be difficult if we were actually doing this experiment to see what that change specifically looks like. But let's assume that that mixture could become more green, more red-brown, more blue, depending on what shifts are made. So it says, write the equilibrium expression for this reaction system in the syringe. And so our equilibrium system is going to have the products over the reactants. So I'm going to have my vanadium oxide ions raised to their coefficient, the hydrogen ions raised to the coefficient of 4, bromide ions to the coefficient of 2. That will be over the reactants. So I get my vanadium-3 ions raised to the coefficient of 2. Waters are a liquid in an aqueous solution, so they don't actually have a molar concentration, so they don't make it into the Kc expression. If the water is gaseous or dissolved in like an alcohol or something like that, then it would make it into the Kc expression. But in this case, it's just pure liquid water in an aqueous solution. So you can't get mole per liter concentration. Bromines, on the other hand, are aqueous. So my bromines get in there, Br2, and they're raised to the power of 1 because that's its coefficient. So here's how we're going to get our equilibrium expression. It says, what color changes would be expected if you added vanadium-3 nitrate solution to the system? So if you had vanadium-3 nitrate, you're going to get vanadium ions and nitrate ions. So essentially what we're doing is we're adding vanadium-3s. So I'm going to shift the reaction to use up the vanadium-3s that were added, so it shifts the reaction to the products. I'm going to get more blue color, and it's going to start off by, when I add the vanadium-3s, are going to be green. So the green color increases, and then as it shifts the equilibrium, that green color is going to go away. A little bit of the red-brown will go away, and it'll get slightly more blue. What effect would adding a catalyst have on the system if it is at equilibrium? Well, any system at equilibrium, a catalyst does not shift the equilibrium position. So it'll be the same equilibrium constant. The equilibrium will be constant. The catalyst does essentially nothing to any concentration. But if the system was not at equilibrium, adding a catalyst speeds up both the forward and the reverse reaction. So it would get to equilibrium faster. And so you'd get that equilibrium system back quicker by having a catalyst. What effect would putting the system under pressure have on the equilibrium position? Well, in this case, so when we have gaseous systems, when we compress them and put them under pressure, it shifts the equilibrium towards the side with fewer gas molecules. But in this case, neither side have gas molecules. This is an aqueous system. There are no gases. So this would have no effect. So this has no effect. And then it says, what effect would adding silver nitrate to the solution, to the syringe, have on the equilibrium position? So if you add silver nitrate, this is a pretty common chemical to list in a question for high school because silver ions will make a precipitate with many different anions, including bromide. So if I have silver and bromide, the silver ions and the bromide ions will make a solid precipitate. And what they're describing by adding the silver ions is, as you add the silver, you're decreasing the bromides. And so if you remove those bromides, it's going to shift towards the products to replace the bromides that were removed. And they're removed by precipitating them out. Then it says, what effect would adding sodium bromide have on the equilibrium position? Well, that's exactly the opposite. If I have sodium ions and bromide ions, what you're doing is then you're adding bromide, and so it would increase in concentration and shift the equilibrium to use up the bromides. Some of the blue color would go away. I'd get more green and red-brown color in my solution as it shifts towards the reactants. Then finally it says, what effect would adding hydrochloric acid have on the equilibrium position? Well, hydrochloric acid is adding hydrogen ions or hydronium ions. So if you added hydronium ions, it's going to shift this way. This concentration would go up quickly, so its pH would increase, and then as it uses up the hydrogen ions, those would start to go down again. And again, we'd produce more of the green color, more of the red-brown, and that blue color would fade.